Thanks, Joey. I appreciate it. Well, good afternoon, good morning, good evening, wherever you are. It's my pleasure to uh, bring this tech talk to you today on drainage and open roads, going with the flow. So we're going to look at the subsurface utility design and analysis subset of the open roads tools and technology. And so we've had quite a large group, so I hope my goal today is to just kind of impart some information to you, and hopefully I can touch on all the different levels that I'm sure our group has as far as their familiarity with open roads and the drainage offerings that we have in that product. So my focus is going to be 3D. I think subsurface utility design does a great job of presenting our drainage models in 3D, and so you'll see everything I do is kind of from a 3D standpoint. Hopefully we'll show you the dynamic link between your models and your analysis and your calculations. For those of you who aren't familiar with subsurface utility design and analysis, this isn't a brand new set of calculations. We're using the trusted Haystead Methods calculation engine underneath the hood here, and so tried and true calculations that have been accepted all over the world. One of the things that we're going to highlight today is the analysis and looking at scenarios and alternatives. So like I said, my agenda today is very simple. I'm going to kind of create a 3D model, both existing and proposed, and then we'll do some design and analysis and look at how things change and how things update, and hopefully give you a good overview of scenarios. So with that, I'm going to go ahead and jump into a file. And I have a lot to cover, so first thing I'm going to kind of cover real quick is the existing information. One of the things I really love about subsurface utilities is the ability to bring in and apply feature definition to existing survey data. So you can see here in my 3D view, I've got some existing water lines and sanitary sewer lines, and I want to extract that and bring that into a 3D model. So again, kind of keeping my focus here on the 3D. So I'm simply going to come in here and use a utility filter that I've set up, and it's going to extract all the utilities. So if you take the time to set up the filters well, you can quickly and create 3D information. So I've taken the survey data and it's gone through, and you can see on the right hand side it's gone through and created that in 3D. So you get the detail of power poles, you get your water line, you can even get a nice representation of your fire hydrant if you take a little bit of time to set that up correctly, the manholes and so forth. So quickly and efficiently getting your existing data in so that you can start your design properly. So I'm going to jump into my design. So I'll switch to a different file here. And I've referenced in, you can see here, I've already started a little bit for time purposes, but just take a look at, the 3D that we just brought in is there. So if I need it, I have it available through a reference file to use. So with subsurface utility, 3D is really easy to create. So it's nice to be able to look at your project in 3D. So I've got my proposed surface over here on the right-hand side. You can see I've got a pond, a street, and I'm going to go ahead and place an inlet. So what is it? I'm going to assign a feature definition to that inlet, so that and in that feature definition will be all the necessary visual effects of how it looks in plan and how it looks in profile. And I'm going to select a reference element as my elevation. I'm going to select this bottom of the pond over here and use that as my my reference elevation. And then I'm going to come over here in my plan view, or my 2D view, if you will, and you can see it's gathered elevation 1088. So it's reading that elevation, and if I change that, of course, it would update. So I'm kind of locking it to that pond bottom, if you will. And then I can give it a rotation and place it. And you can see over here in 3D, you can see a nice three-dimensional representation of it, and it's on the surface of the bottom of the pond. Now, moving on to maybe another type of structure, we'll go and place an inlet here real quick, and I'll just use this inlet C flat. And I want to place that inlet along an existing element, or in this case, a curb return. One of the things that you can incorporate is AccuDraw. So I'm going to go ahead and select my surface. I'm going to set the surface as my roadway. So it's going to read the roadway surface. But before I place it, I'm going to go ahead and initiate AccuDraw here. Get it going. There. And you can see now I have AccuDraw available. And so if I want to lock into that curb return, I can simply select that element, and now it's locked in its station and offset to that curb return. And so if I want to precisely place inlets, that's real easy to do. And again, I'll lock that into a specific station, for example, and maybe an offset of 0. And so based on that, you can see it's keyed, it's got the elevation from my pavement, and it's placed it at that point. And then of course, if I want to rotate it and make it radial or to that curb return, I can do that. And then of course, I see in 3D. So I can work, pretty quickly. For example, I want to move it to a different reference. I want to reference this center line, and so I want to place it along the center line of that road, maybe at a certain offset or so forth. I can do that just by selecting that element, and now I give it a different station. Oops. Different station value, and maybe a different offset. Obviously, 13 feet to the left, and that'll put me at that location. And again, it's picked up the same pavement surface that I had before. I can rotate that and then see that in 3D. So what exactly is happening here, as you can see, if I select that element, you can see it's locked in some information there, so I can change the offset, I can change the station. I can't change the elevation, that's reading the surface at this point. So if I want to change that, I have to remove the surface definition from that element, and then maybe select a new surface, and we'll look at that in a second. But maybe also I don't want to use that particular type of inlet at all. I can come over here and change its feature definition, and quickly, just simply by changing a different feature definition, I'll get a different looking structure. And you can kind of start to see the detail that you can put in your structures. I'll rotate that so that it's in line with the curb. And I can do the same thing, do that on the other side. Change that one to a different type of structure as well. And you can see it changes it. And then I'll go ahead and rotate that just so it is in line with the curb. So quickly, accurately, being able to create these 3D models. As far as conduits or pipes, go ahead and start the pipe. I don't need Civil AccuDraw right now, so I'll toggle that off for now. I can assign a feature definition here. So if I want to choose a particular type of storm sewer. One thing I want to point out here is that when you're placing pipes, you have connection regions here. And so you can see on this particular structure, I've set up a few connection regions that it can connect to. And so I can kind of limit to what the user, where they can connect their pipe up to the structure. And as I place it, you can see it in 3D as well. So, and certain structures that are circular in nature, for example, you can set a connection region as the entire circle, or you can just, again, have points. And so it makes it real flexible as far as how you want to place pipes and connect them up to your structures. So I'll go ahead and finish that. Now the last component I want to take a look at are what we call polygons or catchments. And so let me set up the view here for us. Let me turn on a level. So I've already pre-set up a couple drainage areas in blue. I've already created a couple of catchment areas for those previous 2 nodes. And I'll go ahead in my 3D view and show you how they look in 3D. So in plan view, I drew a shape that represents my drainage area, and I'm going to pick that shape, and I'm going to assign a feature definition to it. So I'm going to select this shape. I'm going to select the outflow, and I'm assigning a feature definition called residential heavy to that. Now I can plot that in 3D by selecting a reference surface, and it will kind of drape that catchment onto the surface. And so even my catchment areas can be shown and looked at in 3D. I can change the feature definition to something else. pick that, pick its outflow point, its 3D surface, and you can see, again, it drapes it in 3D. So what exactly is stored in those shapes? I can pick the shape, for example, look at its hydraulic properties, and I can see there's, the runoff information stored there. If I were to, select a different shape, I get a different runoff coefficient. And of course, I can override that if I want. So now that I have just the basics of a network, let's go ahead and let me turn off my catchments, just so it visually is more pleasing, and we can see our pipes here. And I'll zoom in. Now I'm going to go ahead and just quickly let's compute the system. So I'm going to compute the system. And when I compute it, you can see it update. So it's now sized the pipes. It's adjusted the the inlets. It's got the inverts at the correct elevation. It's placed the structures deeper if need to be. And so you can kind of see, as once I compute, the model updates. So for example, let me go take a look at a profile. So far in my model, I've got all my inlets and pipes, but I want to create a profile just to kind of look at it in profile. Another nice thing is that you're going to get visual feedback, so you can see all the warning messages. Those are warning messages that something's hydraulically not correct, and so I can hover over those and see what they are, or I can bring them up in a user panel and kind of look at them that way in a report. So I created a profile. Let me take a look at that in analysis profile. So you can see here in the analysis, I ran a 10-year event, and it's kind of bucked the grade on that pipe, so I can see I've got something to fix there. But you can kind of see what you have at this point. We could also, open, for example, if you're familiar with the OpenRoads and the road profiles, we can open a profile model, and I can look at that and profile model. And so let's take a look at, for example, my outlet pipe. I can select that, and I can see, okay, it's got 0.5% grade on it. I can kind of see that visually in 3D. Maybe I want to change that. I can do that right here from the profile model. I can say, let's change that to minus 10%, for example. And you can see that update in the profile and the 3D model as well. So I can change it here in profile. I can grab the pipe, for example, and move it that way. Now, if you remember, we've locked in our elevation for our outlet at 1088, so that one's kind of stuck for now. But I can adjust the other options. So we'll just say like 0.5, for example. Enter, and then of course it updates. Now, if I were to go back and compute that, what's going to happen? Well, it should go through and reset it. And so it's going to reset it back to what its original design was, and that's because, for example, if I were to look at this particular pipe here and look at its hydraulic properties, I can see under design, it's set to design the start invert and design the stop invert. So I could set that to false, and then I could adjust the particular pipe, and then when I redesign it, it wouldn't change. So that's one way you could go through particular pipes that you want to and turn off the design option for those. I could also come here and edit the outlet structure. So for example, I can, as we talked about earlier, that we can change the rotation angle. Currently I can't change the elevation. You can see it's grayed out, but if I try to move it, I can see I can Alt to change the elevation. So if I set the Alt key, I can change the elevation. I can hit the Control key to remove its existing reference, which was the surface, and now I can type in, what I want it to be. So maybe, maybe I need to lower the pond or whatever. I can type that in. So in my case, I typed it at 1080, just so you can visually see that it can adjust. But you can see if I want it at 1087.5, I can raise it up. And now, since I've adjusted it at the node structure, and I go back and compute, it's going to hold that elevation and recompute upstream from there. And the whole time that I've been redesigning or changing things, my analysis profile also updates, so I can see from an analysis standpoint how that affects the system. So I just came over here and clicked on compute, and it's using a 10-year storm event. But let's take a look a little closer at what's going on there. So let's take a look at scenarios, alternatives, and calculation options. So these are kind of the backbone, and if you're a Haystead user and you've used Stormcat or Civil Storm, and for years you're familiar with scenarios, alternatives, and calculation options. These are the power behind the design and analysis of Suda. So being able to understand alternatives, they're just simply a logical, organized set of properties. If I were to expand this, for example, what is an alternative? Here in my base design, for example, I have alternative for whether to design the start or stop invert, or whether to design the pipe. My cover constraints, my slope constraints are all stored here in the design alternative. Do I have a maximum pipe size that I want to stick with? I can say limit the section size. So there's a lot of properties, if you will, and they're kind of logically grouped into different areas here under alternatives. Another one might be physical property, whether I want to, where the pipe sizes are, or the type of pipe. If I want to change the type of pipe from concrete to plastic or whatever, I can change that here under the alternative. So any changes I make to the alternative are picked up by the scenario. So if I look at the scenario, I can see here this particular scenario is using this set of alternatives. And so those happen to be the default or base alternative. So let's, and then this scenario is also using a base design calculation over here. And so under the calculation, under these calculation options, that's where all the different types of properties for calculating your hydraulics are. So let's take a look real quick at, for example, I can see in my profile I have sumps on each node. So maybe I don't want sumps. So that's one scenario or one alternative. So I can come over here under base design, and I want to copy it, if you will. I want to make a child of it. So it's going to copy all the information out of base design, and I'm going to create a new one called no sumps. And so all I'm going to do is go into this particular alternative and find the one property that controls the sump depth, which is desired sump depth, and set it to 0. So I'm going to set them all to 0. Now I want to run that scenario, or run that alternative, so I'll come over to my scenarios, and I'll create a new one, child, and I'll call this no sumps. Now everything in no sumps, if I double click on it, currently everything under this alternative, or this scenario, is inherited from the one that I made it a child of. So it's inherited all its base alternatives from the main one. The only thing I need to change is I want to say no sumps. Make the change, compute, and it will go through and calculate. It'll come back, and I can see in my profile model I have no sumps. I can see in my 3D model I have no sumps, and if I wanted to look at my analysis profile as well, I can see. So you can kind of begin to see some of the things you can start to do. So for example, I'll do another one here. Let me do a new child alternative. We'll call this one my pipes. I want specific pipe sizes. So I'm going to say these are my pipes. So if under the pipe alternative, that's where we store size. And so currently everything's set to 18, and everything's set to circular CMP. or corrugated metal, but I want to change that. So maybe I'm going to set, I want to see if I can get away with smaller pipes. So I'm going to set these to a little bit smaller. Actually, I won't go that small. Let's go 15. And I can change one of them. I can change all of them. I'm going to make this one 18. And I'll just make this one visually bigger so we can see it in 3D 36. So that I've changed my pipes. Now I also need to come down here and change the sumps option, because one thing the sumps and the base design was also doing is it was designing pipes. So I don't want it to design pipes anymore. I want it to use my design or my sizes. So double click on that, and I'm just going to turn off design size or design conduit. So I've made the change. So I'm going to create a new scenario, my pipes, and what can I need to come in and set it to use those two changes. So I want it to use, under the physical alternative, I want it to use my pipe sizes. Under my design alternative, I want it to use my pipes, or not design the pipes. And then of course your naming convention can be however you want as far as you name the alternative, something that makes sense and is logical. And then once I set that, I just compute, have it run through and run the system. And you can see in 3D, you can kind of get to see now, the smaller pipes. And again, what does that look like in analysis? I can see that as well. Continuing along that same logic, another popular thing would be able to change the rainfall. And so let's say, for example, right now I'm calculating everything on the 10-year storm, but I want to do a new storm event. So I want to run a different storm event through here. So I'm going to say create a child alternative, call this 100 year. Oops. And then come and select a different storm event. So here I'll select the 100-year storm. Then I'll come over here to my analysis. I don't want to design it for 100 year. I just want to see what it looks like. So I'm going to come over here and set up a new alternative and call it 100 year. So, and then of course set the particular storm event to 100 year. So it's going to use all these other alternatives and except for the 100 year. So I'm actually going to go ahead and change this back to use my pipes for 100 year. So let's analyze that at the 100 year storm. And then go compute. And then we'll open up our profile and take a look. So if I select my profile, look at my analysis profile, I can see. And so one of the nice things is that you can quickly switch back and forth. So here I can run this scenario. Now this is a design scenario, so things will resize. And you can see that in the profile. So not only does the analysis profile update, not only does the 3D model update, but also in the profile model. So everything's kind of tied together, and so you can take advantage of the exceptional hydraulic computations that are part of the StormCAD hydraulic engine and use that in your Suda design. And so, and one thing I mentioned is all this is part of subsurface utility design and analysis, so there's no extra fee or anything like that associated at this point. If I wanted more complicated analysis, then I could just simply upgrade to StormCAD Unlimited, Civil Storm, SewerCAD, or SewerGems. But until that point, I'm not using any additional licensing or any extra cost there. Okay. Okay, so hopefully you can see that you can create accurate, intelligent 3D utility models. Everything's kind of dynamic and on the fly as you make changes. And as you get your head around scenarios and alternatives, you can really start to really manage and logically look at all your designs in multiple ways. So you can evaluate your design quickly, effectively, without a lot of changes, and setting up preferences and so forth. So once you've got your scenarios and your alternatives kind of set, then you can go through and really reap the full benefit of the Hasted calculation engine. And of course, to me, it's free. This comes with the OpenRoads technology. It's there for you to use. And so if you're familiar with the StormCAD and are able to understand that, then this is a simple transition into the 3D world of OpenRoads. And with that, I have one more thing. Let me just quickly mention, while I have the software open, is that when you install the latest version, you'll get the Connect Advisor. And so this is your one-stop shop for accessing not only help or technical support or training, but you can search and look through the wiki articles. So for example, if I type Suda here, it's going to show me, it's going to show me everything, revolving around Suda. If I type, if I want to just filter on YouTube or communities, I can do that. So I can say just show me the communities, and so now I can see if I want to click on one of these, I can, and it'll take me right to it. So for example, the question came up the other day, can I delete a Suda model? And the answer is currently no, you can't delete a Suda model. So you can, if you get stuck, it's a good place to search a question or see what's coming up as far as learn or events. And with that, I'd like to open it up for questions.